Hey guys, all right, I'm going to do another video on binomial probabilities in case you need some extra help. All right, also feel free to contact me anytime for extra help. All right, I'm going to try to share a PowerPoint with you. Let's see if it's going to be okay with that today. Some days it's good, some days it's not. Okay, let's see if today's a good day. We'll look at there. Today's a good day. Okay. Last time on the video that you watched, I kind of showed you the formula, but that formula is built into your calculators. Okay, so I do want to make sure that on the test, most of you are not going to choose to do the formula by hand. Of course, you're going to choose to let the calculator do the work, and that's what I would do too. Okay, so I'm just going to kind of walk you through 4 parts of an example strictly using the calculator in case you need some extra help with the calculator. Now, this was kind of the last slide on the previous video, probably, that you've already watched. If you want to use the calculator, you've got to get to the binomial distribution on your calculator. So in order to do that, you hit your second key and then your vars, V-A-R-S key. So second and vars gets you to a whole bunch of things on a menu. My first thing says normal PDF and then normal CDF and lots of things below that. If you notice, when you get down to the bottom, like number 7's got an arrow pointing down, that means there's things below that. So keep scrolling all the way down. All right, on mine, 0 is binomial PDF and A is binomial CDF. It might be different on your machine depending on the order, but you keep scrolling down until you can find binomial PDF and you can find binomial CDF because we're doing binomial probabilities. Now, remember, there's a difference. How do you know when to pick the binomial PDF versus the binomial CDF? It depends on what's sitting next to X when you write the problem out. If you've got exactly one number and one number only next to X, you're going to use the binomial P for one particular value. Okay? Now, when are you going to use the binomial CDF? Well, if you look next to X and there's a whole list of numbers and that list starts with 0. All right, so it's 2 conditions. It's more than one number next to X, plus that list of numbers must start with 0. If that list doesn't start with 0, game over. So if you see a list of numbers that begins with 0, then you do the binomial CDF, and C is for cumulative, okay? Now, the order that you type it in matters because if you type the order in the parenthesis wrong, it's going to give you an error message. Now, some of you have a newer version, and it probably says like number of trials. That would be your N, all right? Your successes would be your X, all right? So if you've got a different machine and you can't figure it out, let me look at it and see if I can kind of help you with that. Okay. Now let's go look at some and work our way through them and make sure we're clear. All right. Let me kind of move this a little higher to get it off the problem. All right. Look what it says. 10% of the general population is left-handed, which by the way is true. All right. So if I randomly select 10 people, just 10 people out of the general population, I want to find the probability that exactly 2 are left-handed. Now, remember what I told you. If it's probability, you don't have a P and in parenthesis what you're looking for, I'm not going to give you any partial credit. So if you're off by 1/10,000th, I'm going to count the whole thing wrong. Okay. And the reason I'm so strict about that is I have found through the years that when you do what I tell you to do, life is good. Okay. So we're going to hopefully do what I tell you to do. So put your P. I found that probably that exactly 2 are left-handed. All right. So how do I know it's binomial? Well, there's only 2 categories. Either you're left-handed or you're right-handed. Is your chance of being left-handed the same for this whole problem? Yes, 10%. Okay. So my N is my total in every problem. So that's 10. I was picking 10 people. X is the number with modifiers in the parenthesis. So exactly 2 is only the number 2. Now you've got 2 categories. Our categories are right-handed and left-handed. So I look in the parenthesis to see which category is in the parenthesis. I don't look at the number. So I'm just covering all that up and I'm just looking at the category, left-handed. So the chance of being left-handed according to the problem is 10%. So when you write 10% as a decimal, you get 0.10 or just 0.1. That's what it reduces to. But if you want to put 0.10, that would be fine. Remember, the way you get Q is 1 minus P. So 1 minus decimal 1 is decimal 9 or 9/10. So I expect you to have a P and what you're looking for, and I expect you to tell me what N, X, P, and Q are. Otherwise, you'll get no partial credit. Now, how do I decide whether to do binomial P or binomial C? All right, look at your X. You see there's one number there. When there's one number, that's how I need to do binomial PDF. All right, particular value, one number, pick the P one. You've got to type it in the order N, P, and X, not N, X, and P. I mean, I didn't program it. I would have programmed it differently, but we've got to go with what the machine is expecting. So I look over here and my N is 10. So that's why there's a 10. I got to put a comma. Remember that comma is above your 7 on your keyboard, kind of on your calculator. Then I've got to put P. So I glance down here and P is 0.1. So there's my 0.1, my 1/10. It's expecting X. So I look down here and X is 2. So I type all that in my machine. And when I do, I get a really long number. And remember, on probabilities, I want 3 or 4 decimal places at least. So you can round on probability. If you round to less than 3 or 4, I'm going to count off. All right, we're not going to be lazy. Okay. Now, you can't round off to 3 or 4 if that rounds to 0 or 1. But I do not want you giving me 0 or 1 rounding it. So if you got to go 95 places, then you go 95 places to keep from rounding to 0 or 1. Okay. So double check that, like freeze it. I want you to double check and make sure that when you type that in your machine that you get that. 0.1937. The next number was a 1. That's why that stayed a 7. So you freeze it, type that in your machine and make sure that you can get that answer. All right, hopefully you followed my instruction and you got that answer. So now let's look at this next problem. 10% of the population is left-handed, still picking 10 people. But now I want the probability that exactly 7 are right-handed. Sometimes they'll switch the category on you in the problem that they're asking from what they've got written in the word problem. So that's one of the reasons for making you write it out. I'm trying to find the probability that exactly 7 are right-handed. So N's my total, so I'm still picking 10. X is the number in the parenthesis. So exactly 7 is just the number 7. What category is in the parenthesis now, though it doesn't say right hand, it says right-handed, not left-handed. So do you understand that if 10% are left-handed, that means the rest must be right-handed. So all of it's 100% minus your 10% is 90%. So if 10% are left-handed, the remaining 90% must be right-handed. So that's why I have 0.9 next to P, because it's got to match the category. And then 1 minus P gives me Q. So 1 minus 9/10 is 1/10. So notice there's one number next to X. So that's how I'm going to do the P one. My N is 10. My P is 0.9 and my X is 7. All right. So when I did that, I typed all that in my machine. Remember, to get to binomial PDF, you do second VARs, scroll down until you find it, type that in and double check and make sure that you get the same answer that I got. So the next number on mine, I had 0.05. All right, 7, 3, 9. So because I had a 3, 9, that's why that one turned into a 4. So I rounded off. We're not going to chop off. If you have a 3 right there, I'm going to count off. So if you chop off the number, I'm going to chop off your grade. Okay, so we're rounding off. All right, correctly, mathematically correctly. So freeze this and make sure again that you can type that in your machine and that you get the same answer that I got. All right, hopefully you're back. So now we're going to do this one. Still 10% of the population is left-handed, still picking 10 people. Find the probability that at most 2 are left-handed. So I put in here probability that at most 2 are left-handed. Now, what does it mean when it says at most 2? At most does not mean more than. All right, at most means that that's the cap, that's the maximum. So at most 2 means 0 or 1 or 2. Okay. Now, if it had said less than 2, I would just have 0 or 1. So you got to know what these you got to be able to do some English. At most 2 means 2 or below. Okay. And then which category is in the parentheses now? Well, it says left-handed, 10% are left-handed. So P is 0.1. 1 minus P gives me Q. So that's where I got the 0.9. Now, this time, I don't have one number next to X. I got a bunch of numbers next to X. Bunch is in more than one. Okay, I got a list. But the list has to start with 0. See, my list does start with 0. So it makes both conditions, a list, and it starts with 0. So that's when I can use the binomial CDF. All right, binomial CDF. So I have to do N, P, and X. So N is 10, my P is 0.1. Now, I got a bunch of numbers next to X. It's expecting you to give it the biggest number next to X. And here's the reason why. Remember, I told you the list has to start with 0. So when you do the C one, it's going to start with 0, whether you want it to or not. It's just got to know where to stop. So if you've got binomial CDF, your X is your biggest X. So that's why I put a 2 right there. All right. So again, you go to second pairs. Right, you scroll down on your machine until you find binomial CDF. You type in your 10, your 1/10, and your 2, and then you round that to 4 decimal places. And this next number was a 0, so that stayed an 8. So you freeze this and type that in your machine and make sure that you agree with this final answer that I got. Okay. All right, let's try one more. After hopefully you froze it and you're doing that. 10% are left-handed, 10 people are picked. Find the probability that at least 8 are right-handed. All right, so the probability that at least 8 are right-handed. Now, again, at least does not mean less than. At least mean that's my minimum. So at least 8 means 8 or more. So that's why I have X being 8 or 9 or 10. I stopped with 10 because that was my total. Okay. Now, my P is my category in the parentheses. So this time my category is right-handed. So that's why it's 0.9, because 90% are right-handed. 1 minus 9/10 is 1/10. So do you understand where I got these numbers from? Now, I can't use the P key because I've got a list, but I can't use the C key either because my list doesn't start with 0. So the P is for one number. The C is for a list that starts with 0. So I'm stuck. So how am I going to do this problem? Well, we talked about it last time, but let me reiterate. I could use the P key 3 times. I could let X be 8 and get that answer and save it. I could let X just be 9, one number 9, and use the P key and get that answer and save it. Then I could redo the whole thing with the P key, the binomial PDF. All right. And I could let X be 10 and get that answer. Now, because these are connected with ORs, remember with ORs, you add the probabilities. So I could take this answer, and this answer, and add it up. Now, that wouldn't be terrible because, you can do it real fast on your calculator. So if you wanted to do it that way, you could, and you would get full credit on your test. I'm not going to do it that way. That's too much trouble. Now, if it said that you're picking 30 people, and what's the chance that at least 8 are right-handed? You'd have 8 or 9 or 10 or 11 all the way to or 30. That would be awful to do them individually and add them up, but it's humanly possible. Okay. But if you've got a list that does not start with 0, you've either got to do individual ones and add them all up, or you do 1 minus the complement. All right. So for me, as soon as I glance at a problem and I say, oh, that's too much trouble, if it's a probability problem, then the next thought that comes in my head is, well, I could do 1 minus the probability of the complement. And usually I'll go set that up and see if that looks better. So remember what the complement means. The complement means everything that's missing over here next to X. Now, remember, if you pick 10 people, how many might be right-handed? Well, 0 or 1 or 2 or 3, all the way to or 10. So which numbers that are possible are missing? Do you see 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7? All those numbers are possible, but they're missing. That makes them my complement. So 0 all the way to 7, the same category. If this category is right-handed, that category is going to be right-handed. So this is my complement. So what I can do now is I can take this problem right here, and I can start over. I'm going to go up here and highlight it. I'm going to go work this problem that I've highlighted. So I'm starting over. I'm going to work that problem binomially. So on this problem, n is still 10, but now my x's are 0 to 7. Right hand is still my category, so P is 90%, so 0.9. Q is 1 minus that, so 0.1. Now, why do I like this setup better than this setup? I mean, this one's longer. It's because I've got a list, and this time my list starts with 0. See, over here, I've got a shorter list, but it doesn't start with 0, so I'm kind of nailed. So I don't care how long the list is. If it starts with 0, that's a better option. So because I've got a list that starts with 0, I can do binomial CDF. So remember, I put my n first, so that's 10. I put my P next, so that's 0.9, and I got to put the biggest x, so 7. And when I did, and I rounded that to 4 decimal places, I got this blue number. Now, what am I going to do with that blue number? I'm going to put it right in that blank. So this is the answer to this highlighted problem, but my answer is 1 minus this one. So I came down here, did 1 minus that, and got this final answer here. All right, so do you understand if you do the probability of this complement? Okay. When you're finished, you got to remember to take that thing and subtract it from 1. Okay. All right, so are we good? So you freeze it and make sure you can type all that in and get that same correct answer. Okay. Are we good? Everybody okay? Okay. Now, when I did this, it kind of messed it up. So make sure that if you're taking notes, you might want to go back before I highlighted that and make sure you're taking notes. Anytime you're doing all these, you need to make sure that you're freezing this thing and you're taking notes on it. Okay. So go try some of those same problems, maybe on the last PowerPoint, and work through them and make sure. All right. So on your homework, second theirs, and then look for binomial PDF or binomial CDF. P when you've got one number next to X. The C one when you've got a list that starts with 0. If you don't have a list that starts with 0, you're probably going to want to do 1 minus the probability of the complement. Okay. If you need something, let me know. All right. See you next time.